Do you want to learn how to get started with the AWS CDK and TypeScript? If that is the case, then this is the video for you. We're going to be going through right the way from the very start and setting up your first project, to building your first Lambda functions, then even creating constructs, adding tests, and creating a pipeline, all using the CDK. By the end of this tutorial, you'll be able to go away and build your own solutions using the CDK and TypeScript. So here is the start of the TypeScript workshop that is now updated with Node 20 and using the SDK version 3. So this first page just basically says there might be some costs, but if you're using a new AWS account or if you only use it for personal use, it should lie under the free usage limits that come with any AWS account. So you shouldn't have to worry about any of that, but it's always good to clean things up. So to start, we need to go into our new project. And here it is saying that we need to init our project, and I'll just move my face out of the way. And it's saying we need to use CDK init to create our project. So if we go on to the next page, here it's saying that we need to make our workshop directory and CD into it. So I'm just going to copy this, head over to a terminal, and in here I'm going to CD into where I want to create my repo, which is in the POC folder in my computer, and then make directory CDK workshop and CD into there. Now if we go back into our tutorial, here we can use CDK init. We're using the sample app, and we're going to be using the language of TypeScript, obviously. So paste that in here, and this will basically create our boilerplate for our repo. This does take a couple of seconds to do and install all the packages, so I'll get back to you when that is done. Now that that has completed, we can see that we have a basic setup for our CDK project. And what we can look at is if we look in the bin, which is where we create our application, we have a new app, and that app uses the CDK workshop stack. And yeah, that is being imported from lib CDK workshop, which we can look at now. And in here, I'll zoom out one tab, and in here we can basically see and define all of the resources inside our stack. So by default there is a queue, a topic, and then that topic is subscribing to the SQS queue. So if we go back over to the tutorial, you can scroll through, and then we can go on to the project structure, which kind of just explains what we were talking about, where there is the bin, the lib, and the test folder, and we'll talk about tests a little bit later. We can now run a CDK Synth command, which will take all of our TypeScript code and will basically generate the CloudFormation template. So if we open up a terminal and run CDK Synth, this will generate a CDK out, and it actually generates our CloudFormation template in our console as well. So with that generated, we now have the equivalent of this whole massive thing, and we can look through and see our queue, our topic, and our subscriptions. So if we open up CDK out and look at our template.json, we can scroll through and see our SQS queue and other things inside our template, but most of the time we don't need to really look at the CDK out. We just need to know that if we do need to, it is there for us to look through. So next we can move on to CDK deploy, and this is the fun part where we actually get to deploy some stuff. Because this is the first time we're deploying this repo, we actually need to run a CDK bootstrap command. So I'm going to run over to my terminal again, and in here run CDK bootstrap, and this kind of just prepares the environment so that we have somewhere that we need to deploy our code into. So now that we've done CDK bootstrap, we can scroll down and get ready to actually start deploying. So all we need to do is run CDK deploy. And what this will do is this will package everything together, build it, and then it gives you a question saying there are some security related changes. Do you want to make them? We can just say yes, as we do actually want to make these changes. And now what will happen is this will be deployed into CloudFormation. And once those CloudFormation changes have been enacted, then we'll be able to actually look into the console and see our deployed resources, but then actually call whatever functionality we've created. So that has now finished deploying in 24 seconds, and we have the stack ARN. If we now go across into our AWS account, and this is the AWS account I've been using in the region I'm using, which is Frankfurt, then we can go in CloudFormation, and we can see that we had a CDK workshop stack deployed earlier today, or just now even. And if we can click into there, what we see, if we just close some of this to make it a little bit easier, if we click on resources, we can see that we have the workshop queue, the workshop topic. So that is all of the resources that we have just deployed. So that is basically deploying with the CDK, but now we want to actually create our own application. So first we're going to go in here, and what we're going to create is a simple API, and that API is going to have a Lambda behind it to basically just send a message back. So the first thing we need to do is actually clean up the existing deployment, because we don't want to have that SQS queue lying around. So we need to go into our workshop stack in our libraries folder and basically clear out everything that is in there already. So if we close this and then go to our lib, I'm just going to close this as well. What we can do is delete the queue and the topic just like that. And then we are ready here to create our resources. We can also clear up some of the imports at the top like that, just so it's a little bit cleaner. Now we have that, we can actually check what happens if we deployed our current project. So again, open up the terminal, and what we're going to do is we're going to run CDK diff this time, and this is basically going to give us the difference between the stack as it is now and what is currently deployed. So this does take a little second to comply, and here it tells you that you actually get a full table. If I make this a bit bigger, that there is a change to the I am statements, because we're removing the role which allows SQS to send messages. And then we're also removing the SQS queue, the queue policy, the SNS subscription, and the SNS topic. So if we actually want to enact that, we can scroll down and copy the command CDK deploy. And this is basically going to deploy a stack that doesn't actually have anything in it, because we don't have anything defined inside our CDK stack in here. This may take a couple of seconds just to deploy, and then we can move on to the next step. So the next step, once that's deploying, is to create a hello lambda. Now we need to create a directory where we want to keep all of our code. So we're going to create a lambda folder at the same level as all of the other folders. So I'm going to create a new folder called lambda, and in here I'm going to create a new file called hello.ts. And now that we have our hello.ts file, we can go and basically copy this code, and this is just a basic lambda handler function which takes an event from API gateway, and we're just going to straight return an event with 200 response saying it's successful. It's just a plain text response saying hello CDK, you've hit, and then the URL that we've tried to hit. So if we just copy all of that and paste that in here, save that, now we can see that just in time our CDK has finished deploying, which means we've deleted all of our resources, and we can now see that we have our lambda code, but we actually need to tell the CDK that here is a lambda and I want to add this to my stack. So if we go back to the tutorial and scroll down, we need to install the Lambda construct library. And if we go down, we can go all the way down to here. And what we need to do is add this section to our AWS stack. So I'm just going to copy this and go to lib and our stack. And underneath the word super, we can paste this. Now, as you can see, there are some issues because we haven't got some of our dependencies. The Node.js functions, if we quick import, we can import that from AWS CDK lib, and it's AWS Lambda Node.js to give us our Node.js function constructor. With Lambda, it's a little bit different. If we go across here, we can see import everything from Lambda. So I'm going to copy this and add this to the top of the file and change this to a star. And now we are importing the Lambda construct from AWS Lambda, which gives us things like the different runtimes as well as other parameters. So this is, instead of hard coding a value, we're using the runtime. For example, if I delete this and put underscore, you can actually see all of the different options available for the runtime. We're going to go with 20_x because it is the latest version, and it's nice to use the latest version. If you do need to, you can use an older version, but eventually they will be deprecated. So here you can see that 4, 6, 8, 10, 12, and 14, these are all old Lambda runtimes that are now deprecated, which means they aren't used anymore. The last part is the path, and this is just a node function, so import star as path from path, which just allows us to say basically where is our code, and our code is down one directory into the Lambda directory, and then it's hello.ts. So we're using this path.join to allow us to do a relative path. And finally, we have our handler, and that is basically saying the function name in here, and it is traditionally used to call the word handler is the function name inside your Lambda, and we just need to make sure that that matches here. Now that we have that, we can go back to our tutorial and scroll down, and this is just explaining what I did about the fact we're using node 12. We've got our Lambda code in lambda hello.ts, and we're using the name of the function handler. The next section of the tutorial explains about constructs and constructors. So if we look at our code, we are inside our CDK workshop. We are creating this stack, passing in a scope. As you can see here, there's a scope, an ID, and then some props. Here we're passing up the app as the scope. This is the ID, and we don't pass up any props for this. And then if you look inside, for example, our Node.js function, we have our scope, which is this. So this is binding the Node.js function to this stack. We're giving it a ID of hello handler, and then giving it some props. So this is how you work with any of constructs, whether they are default ones from AWS, like this Node.js function, or if they are custom constructs, which we'll see later, which basically allow you to create a kind of template which says, passes up some parameters, and will create you a set of infrastructure that does a certain set of functionality. So that's just talking about scope, ID, and props. So now that we've actually made some changes, we can actually run that CDK diff again. So CDK diff. Make sure that we actually save all of the files before running CDK diff. And what will happen here is, now that we are using the Node.js function, because we are actually writing our code in TypeScript, but we want to deploy our file in Node.js, which has to be just JavaScript, we actually have to use Docker to turn the TypeScript code into JavaScript code. So when you run CDK diff, what it does is it uses Docker, and if you haven't got Docker installed, there'll be a link underneath this video. It uses Docker, it will install the Docker file, which is needed to basically say, this is how you translate from TypeScript to JavaScript, and then it will go through and it will run the build, and then generate this CDK out, and this CDK out will have our index.js, and if we scroll down we can kind of see something that looks a lot like the TypeScript code we've written, and this is our built JavaScript file which comes automatically from our TypeScript. So that is a really nice way of doing it, so that you just have your TypeScript files, but you know that it will be built into JavaScript when it is needed. If we scroll down a little bit more inside our output, inside our terminal, we can see that there is a new resource of hello handler. And then we also have a new IAM policy, which is the role that this handler will have. And again, at the bottom, you can see this. You can see there's a new IAM role and a new function. So those are the two things that we expected to see. So we can scroll down in here, and the next step is to just deploy this. So in here, just run CDK deploy, and this will deploy, well, it will rebuild our Lambda code in case we've changed it. Then it will create the CloudFormation template, and here it's saying that there are some security changes because we're creating or modifying an IAM role. Do I want to continue? I want to say yes, because I do actually want this to deploy, and this will now update our CloudFormation template and send that off to AWS, and as you can see, it is now updating in progress. If we go over to our AWS SDK and refresh this, we can see that at the bottom it says update in progress, and in here, if we go to events, we can see that it is creating our Lambda service role and it is creating our workshop stack. This takes a couple of seconds to deploy, and I'll get back to you when that is done. Now that that has finished deploying, we can actually test out our function. If we scroll across to our CDK workshop and go on to resources and refresh this, we can see that we have the hello handler. If we open that up, we can actually access directly the Lambda function. So I'm going to click on this. This opens up our function where we can actually see our code. If we click on our index.js, this is our built JavaScript file. And as you can see here, there is basically the code that we'd written. But what we want to do is we actually want to test it. So if we click on test, we have to create a new test, and this is going to be a mock API. And if we scroll down, we want to change the template from hello world to a HTTP API, because this is going to be coming through API Gateway, and this is our API Gateway example test. Now, if we look at our code, here we're expecting event.path to be a value. So we need to make sure that in our event, we have a path in our event. And I'm just going to copy this value here and paste that in. And now when we save this, we can actually go and hit test. And as you can see here, we get a successful response of 200 with hello CDK, you've hit path to resource, which is exactly what we expect to get back, which is great. So now that we've done that and we've gone through and tested our API, we can actually go on to the next stage. Now, obviously, if you want to, you can just every time you make a change, run CDK deploy. But as you saw here, it takes like 42 seconds to deploy the stack and a total time of 47 seconds. Then that's obviously not the quickest level of feedback. So what we're going to do is we're going to try a couple of other things to kind of speed up our development process. So one thing you can do is you can use something called CDK deploy hot swap. And what that will do is that will basically just only switch out the code inside the Lambdas. But before we do that, we need to find out how fast CDK deploy actually is. So let's make one small change just to the Lambda code. So in hello TS, we're going to change it from hello CDK to good morning CDK. So change that here, save this, and run CDK deploy. This will take our whole repo and it will rebuild it and turn out the changes and then deploy that to AWS, but deploying the whole stack instead of just deploying the Lambda function code, which is the only thing that's actually changed. As you can see, it took 22 seconds for the CloudFormation to deploy and a total of 29 seconds, which the extra 7 seconds come from building it and generating the JavaScript code beforehand. But obviously 30 seconds to make a change as simple as changing 2 words is not that great. So what we can do is scroll down and learn about hot swap deploys. Now if we copy the CDK deploy -- hot swap and make another change to our code. So here we're going to say good afternoon CDK and run CDK deploy hot swap. We should hopefully see a different amount of time taken to deploy this endpoint. There we go. So it took 2.4 seconds to actually deploy it and a total of 6.8, including turning that TypeScript into JavaScript. And yeah, this is exactly the same as you see inside the example. And they point out very clearly in the tutorial that we need to check if the code has actually changed. So if we go across to our AWS account and we open our, I'm going to refresh the page and make sure that when I open up the code section and open up index.js, if we scroll down here, we can see that yes, our code has changed to good afternoon, not good morning or hello. So that means that this hot swap has worked, but obviously you don't always want to have to go back into your terminal and run a command every single time. So we can take this one step further with CDK Watch. So I'm just going to copy CDK Watch. And what this will do is this will watch your Lambda code, and if any of your code, or even if your stack code changes, it will deploy it. It will always try and do a CDK deploy hot swap if possible, but if obviously there's a change to your infrastructure, if you're adding a Dynamo table, it'll have to do a full CDK deploy. If you always want to do a CDK full deploy for some reason, you can say no hot swap, but I don't see any use cases for ever needing that. So if we go into our code, into our terminal and run CDK Watch, what will happen is it will say that it's going to build our new repo and deploy it. And once this is done, we'll be watching our changes. So if in here we say good evening and just save the file, it detects a change in our TypeScript file, automatically builds it and deploys it. And there we go, 5.97 seconds to deploy that change. And I can change this as many times as I want. And every time I save it, so if I say good evening, sir, and save this, this will deploy again. So I don't have to go into the terminal each time to run the CDK deploy functionality. This is really nice because it allows you to have a much quicker feedback cycle. I can make a change, save it, and then test the API or test the functionality. And yeah, in 6 seconds, I can be testing my API change in real time, which is really nice. Now, if we go down to here, we can see that CDK Watch actually has to look at the watch section in our CDK JSON file. So if we go across and look down to CDK JSON, and I'm just going to make this a bit smaller, by default, we have some details. We have the app, we have context, but the section we're interested here in is our watch. And this just defines which files and which folders should be watched inside our repo. And if those change, then it will deploy create a new deployment. So this is, I think, the default one, where it includes everything, but then has an explicit exclude. So if you change the README, or if you change any JavaScript files, or the TypeScript JSON or package JSON, then it won't actually redeploy if you make any changes to this, or to the tests folder, which is really important because you don't want to be redeploying every time you update a test. You can obviously modify this, so if you need to watch some JavaScript files, you can remove this line. Or if you want, instead of including everything, you could say, I only want you to watch the Lambda folder, lib folder, and the bin folder. So that's explicitly including certain things, but that's just a different approach. But for us, this has worked fine. In the tutorial, it does say that you can basically include and exclude whatever you want. And as we've just shown, we were able to change it. In this case, the tutorial says change it to good night. And as we saw, we were able to change the code and see the change appear in AWS in even less time than what the tutorial said. So the last thing we need to do in our wrap is, if we look inside our code, this is going to be watching our changes forever. So if we want to kill it, you can just press Command C, and that will just end the watching process. So if we make a change, it won't deploy anymore. Now that we've finished our CDK Watch and we've seen that work, we're going to extend our functionality by adding API Gateway. So what we need to do is we need to go back to our workshop stack and basically add an API Gateway. We do that by importing star as API Gateway from the AWS CDK lib. I'm going to go back into here, go back to my stack, scroll to the top, and it doesn't really matter what order you import these in, but I prefer to have the path underneath because that is separate. Then the CDK libs, I tend to try and keep those together. So now that we've imported API Gateway, we can go down here and we can see that we need to create a new API Gateway, Lambda REST API. And what we're going to do is pass in a handler and the endpoint. So if I just copy all of this, head back to our constructor, and then underneath our hello, we can save this. So here we are actually passing in the function we created in the first into this Lambda REST API and save that. If we go back to our tutorial, we can again run CDK diff to see the difference between what we've created and what exists already. So let's just do that, CDK diff. This obviously rebuilds our Lambda, but that's okay. And once this is done and the change set is calculated, we'll be able to see. So we can see here that we're adding quite a lot of things. We're adding a REST API Gateway REST API, a deployment, a stage, we're adding a resource, we're adding a permission so that the API Gateway and the Lambda function can integrate and talk together. We're adding a method onto the API Gateway. So these are all the different resources. And if we go down to here, we can see that we've also got one extra output, which is the endpoint. Since we're happy with all of this, we can run CDK deploy. For this, we can't just run CDK deploy hot swap because we actually are changing infrastructure. Again, this is because we're changing some IAM roles. We need to confirm that we're happy to actually deploy these changes. So I'm going to hit yes. And then this is going to actually create our CloudFormation change set and deploy this to AWS. Once this is done, we'll see what we end up with. So now that this has all finished, we can see it took 37 seconds to deploy. We end up with an output of a URL. So if we open this up, we can copy this, just go into our code, and if we open up a new tab, paste in our URL here, what we'll get is, "Good evening, sir, you've hit /", which is exactly what we'd expect because we've hit /. If we change this and do nonsense, refresh the page, "Good evening, sir, you've hit /nonsense", which is exactly what we would expect. So if we go back to our tutorial, that's exactly what it says. You expect to have a stack output, and that gives us a URL. And if you go to it, you see the goodnight CDK or hello CDK, whichever API endpoint code you have still in your Lambda. And if it didn't work, then there are a couple of things. If there's a 500 error, then it could be that your Lambda code is incorrectly configured, or the response back from your code isn't correct. But if you followed this tutorial closely, then you should have a successful API. So this is Sam from the future as I'm editing this video, and I've realized that this is a much bigger project than I first expected. So if you are liking this and you've learned something so far in the tutorial, I'd really appreciate it if you smash that like button, as it really helps share this tutorial with more people who want to learn about AWS and the CDK. So as we learned about in the last video, creating constructs or using constructs is a really useful thing. It's how you create a Lambda function, it's how you create an SNS topic or a queue, and there are ways that we can actually create more complicated or more advanced functionality by writing our own constructs. In this chapter, we're going to create something called a hit counter, and what happens is there's going to be an API that hits our Lambda function, and this Lambda function is going to say, I've just had an API hit, I'm going to write the URL that has called this endpoint to a Dynamo table, and then I'm going to call the function that we actually wanted to call in the end, and then pass that response back to the user. But instead of us having to write the Lambda function Dynamo in our CDK stack as a just normal set of resources, we're going to create a hit counter construct, which means we could duplicate this or use it in multiple projects without having to rewrite the whole thing every single time. So if we go into the first part, we need to create a new construct. So in our lib folder, we're going to create a new file called hitcounter.ts. So in here, I'm going to create a new file, hitcounter.ts. And I'm actually going to close my terminal. And in here, what we want to do is actually just copy all of this code. So if I paste that in, I will first explain what it's all doing. So we have our class of hit counter, and that extends construct, which means it's taking all of the stuff from AWS constructs and kind of building on top of it. And here we have our constructor, so it takes the construct, it takes an ID for what we want to call this implementation of our hit counter, and then it takes some props. In this case, we've actually defined our props to be a Lambda to have a downstream, which is going to be an instance of a function. So if we go back to the diagram here, we're going to pass in basically the name of this function so that we know who we're going to pass the request back through to. So if we scroll down and go on to the next section, we actually need to create a Lambda function that is going to write the data to Dynamo and then pass the request onto Lambda and pass it all back. So in our Lambda folder, I'm going to create a new one called hitcounter.ts. So create a new file, hitcounter.ts, and I'm going to copy all of this before explaining what's going on. So paste all of that in here and save this. Now in here we're importing some libraries, but we'll talk about those when we get to them. So as always, we have our handler function, which takes an event, which is an API gateway event. And just for convenience, we are logging out the whole request or the whole event so that we know what's going on. Then, because we need to write something to DynamoDB, we're creating a DynamoDB client, and this DynamoDB client is imported from AWS at AWS SDK / client DynamoDB. And this at AWS SDK means that we're using the version 3 of the AWS SDK. As we can also see above, we've got the at AWS SDK client Lambda and the AWS SDK lib DynamoDB. Those all come from version 3 of the SDK. But obviously these are all redded out. That's because we haven't installed them. So what we need to do is open up our terminal and run npm install, or just I for short, then -D, and this is basically saying this is a dev dependency. By default, inside AWS Lambda version node 20, the SDK version 3 is already installed. That means we don't need to include the code in our deployments, which is really nice because, yeah, that would add extra size to our deployment and increase the time it takes for cold starts. So I'm going to use npm I to install these 3 packages. And whilst that is happening, I'm just going to carry on explaining what we're doing. So in here, we can see that we have created our Dynamo client. And Dynamo has some weird features to it, which I'll explain a little bit later, but where instead of storing it just as an object, it stores it where each key points to an object with an identifier, and that identifier then points to the value. So instead of using the Dynamo client directly, I prefer to use the DynamoDB document client, which just allows us to deal in normal JSON objects. So we import that from the AWS SDK client lib DynamoDB. Sorry, you can't see that behind my face, but that is what is going on there. And now we have our document client. We do the same thing for our Lambda client because we need that to invoke the other Lambda. Now we actually want to start writing things to DynamoDB. So we want to write something to the hits table. We have a Dynamo table, and that contains all of the URLs and how many times they've been hit. And that's going to be inside our environment variables, which we'll talk about later. The key for the record that we're going to actually write to is going to be event.path, as we saw before. And we're going to update that record by adding hits to increment. And increment is going to be 1. So basically we're going to add hits plus 1, which is just going to increase that number by 1. So that is the input that we're going to be creating. We then pass that input into an update command to generate a command, and then use the document client to send that command. And this is a pattern that is very common in the SDK version 3, where you create an input, use that input to generate a command, and then use a client to send the command. We'll see that exact thing happen here, where we need to invoke a Lambda function. So here we're going to invoke, we're passing in a function name, which again we get from environment variables, and pass in a payload, which we're just going to pass the whole event through. We use that input to create a command using the invoke command from Lambda. And then from this command, we are sending it using the Lambda client to get a response. This response is whatever comes back from that other Lambda. We're going to console log this out to see what we actually get back. And then we want to send this back to whoever called this Lambda, in this case, API Gateway. Now, if we actually did call this, we would see that the response and is the payload. We can say here it is a uint8 array blob adapter, which is very complicated to say, but basically means it is not a string. So that means we can't just pass it. What we have to do is we have to turn it into a buffer, and then use that buffer to turn it into a string. And then once we have that string, we can then pass that and send that back. A little bit complicated, but that is the way that Lambda sends responses back. Now that we have that, we can save this. And if we look at our tutorial, we can see that we have the hits table name and the function name, which we was talking about in environment variables. But we actually need to define this function, and there's talk of a dynamo table. So let's have a look at that. If we go back to our hitCounter.ts in our constructs, find that down here. At the moment, this is just empty. So what we need to do is we need to add some things. First, we need to go and add our table. So we're going to use a DynamoDB table, and we're going to call this hits2 or hits, and it's going to have a partition key of path, which is a type of string. To keep this nice and cheap and free in most cases, you can use the billing mode of pay per request, but if you don't do this, it will be a provisioned, which does have a consistent ongoing cost, whereas with pay per request, it doesn't cost you anything unless you are making requests to it. So let's copy this across into our hits counter constructor. Now, as you can see, there are some errors. So if we mouse over this and try and quick fix it, that doesn't seem to work. So let's see where we're importing it from. So we're importing star from AWS CDK, AWS DynamoDB. So go back into here, paste that in and save it. And now we have our table created. What else do we need to do? We need to add our handler. So here you can see the difference is that one of them said const table equals, and another one said this.handler equals. That's because we've created a public accessible read-only field of handler. So if we go back into our constructor and we paste that in just before the actual constructor, this means that there is a public field on the hits counter, which is our handler. This means that we can now go back and create our Node.js function. And if we just copy all of this and paste that in, save this. Again, we need to import path. So I'm just going to import star as path from path. And now we can explain what's going on with this. As before, we've got a Node.js function, it's node 20. There's the handler, because if we look in our Lambda code, we have called our function handler. And the path, we're pointing to lambda /hit counter, exactly as you'd expect. The difference here is there's something new, environment. So here we can define the environment variables for our Lambda function. So we have our downstream function name. So what is the name of the function that we are going to call? And this comes from props.downstream.functionName. Now this props we mentioned a little bit earlier. These are basically variables you can pass in when you create a hit counter. So someone is going to pass up the downstream Lambda function. And what we're doing is we're saying that the function name is going to be the function name of whatever Lambda they pass up. Same with hits table. This time we're referencing the table that we just created, and we're saying that table name is table.tablename. This means that if the Dynamo table name changes, then the value in the the environment variables will be the same no matter what we changed this to. So if we change it from hits2 just to hits and save this, the table name would be different, but it will always match whatever is in this environment variable. So that is what we call late bound functions, where the function name and the table names are dynamically coming from variables or from things that are built during the deployment. This just means that we don't have any hard-coded values, which would cause things to break if other things change. Next, we need to go and actually use this hit counter. So we've now created our constructor, and this is really quite simple. All we need to do is call new hit counter, passing up an ID, and the downstream lambda. So if we go back into the root of our CDK workshop stack, and underneath the hello function, we're going to pass this in. We can import the hit counter from the hit counter constructor, and we're passing this hello function as our downstream function. The other thing we need to change is the function that our API gateway calls. So at the moment it just calls the lambda of hello, but we want to call the lambda from our hello counter. So we need to paste hello with counter in here, but obviously hello with counter has a dynamo table, it has a handler, so we actually just want to point at the function. And that's why if we go back into our hit counter, we have a public read-only value of handler, which is linked to this node function. This means that in our actual constructor, we have access to .handler. So that means this API gateway is going to point to the lambda function inside our hello with counter. So if we save all of that, we've now got everything ready to do a CDK deploy. So if we go back into our terminal and run CDK deploy, make sure everything is saved. And what this will do is this will now deploy our new hit counter and update our API to use that lambda function. It's going to ask us to confirm that we want to make some changes because we're changing some permissions around who can call what. I'm just going to say yes to this. And this will deploy our changes. I'll show you what changes are made once those have completed. So that has finished deploying, so we can head over to our console, and if we go back into our stacks and actually refresh our resources, here we can see that we have our hello handler and we have our hello hit counter. If we open this up, we can see that this has two things. It has something called hits, which is our DynamoDB table, and it has our hits counter handler, which is obviously our lambda function. The fact that this is all automatically grouped into the stacks and the constructors is really quite nice, as it means it's easier to navigate when you've got lots of related resources. But what we really want to do now is if we go back into here, we can see that we have our URL. So I'm going to copy this and I'm going to open up a new tab and access this. So as you can see, when we try and access our URL, we get a message of internal server error. Obviously that's not great, so let's figure out why. Let's look at the tutorial and say what it says to do next. It says that you get a bad gateway, so let's look at what to do. We look at the Lambda console and we find our hit counter Lambda function, and then we're going to actually look into monitoring to see the CloudWatch logs. So let's do exactly that. Let's find our hit counter Lambda and open this up. In here, we can scroll down and look for the monitoring tab and view CloudWatch logs. This opens up the CloudWatch logs, which is where anything that happened inside your Lambda will end up. If we scroll down here, we can see that there is a stream of logs, which is proving that this Lambda is getting called. And if we look in here, we can see there's our request from when we console logged that out. But there is also this, the error. If we scroll through here, we can see there's an access denied exception. And it says because the identity policy doesn't allow DynamoDB update item. So that's because we haven't actually said that our Lambda function is allowed to update DynamoDB. So if we carry on going back in through our tutorial, we can actually start granting permissions. What we need to do is inside our hit counter, if we scroll down, we can see that we need to grant read write data to this handler for this table. So I'm just going to copy this and add that to my repo. So go into our hit counter .ts inside our lib, which has our constructor. Scroll down to underneath our handler and paste this in. So it's saying this table is granting read-write access to this handler, which seems pretty simple. If we save this, we can now run CDK deploy one more time, which should ask us first to confirm that we want to make a change around IAM, because we're adding an IAM role. So this is saying, if we make this terminal a little bit bigger, that the hello counter hits Dynamo Dable is going to allow Dynamo batch get, Dynamo read, Dynamo write, all of the basically methods on Dynamo to the hits counter handler. So that's exactly what we want. So I'm going to hit yes to confirm this. And then once that's deployed, we can try our API again. Now that has finished deploying, we can go over and actually refresh our endpoint, but we're still getting an internal server error. If we go across to our console, if we now scroll down, we should see that we had our original error, and our original error was the identity DynamoDB update not being there. But if we go down to here, we can see that there is an error because we don't have the permission to do a Lambda invoke function. As we saw at the start in our tutorial diagram, we are going to be invoking that function, the hello function, but we obviously don't have permissions to do that. So let's see what the tutorial says to do. So it says that even though we get an error, we should actually also be able to see the record in Dynamo. So that's something we can also check on. So if we open up DynamoDB and find our, actually let's go for it through CloudFormation. If we go into here and hit our hits table, open this up, this should bring us directly to our Dynamo table. And inside here we can click explore items. And if we click on scan and hit run, we can see there is one item, / and there's been one hit. If we actually go and basically refresh this page, although we're still getting an internal server error, if we update our table, we can see that there's been a second hit. So we are successfully, if we look at our code, we are successfully making the update item request to DynamoDB, but when we try and invoke this function, that's where our error is now coming from. So if we go down, we need to basically give permissions to this Lambda to call another Lambda. So the way that we do that is we say get our downstream Lambda, which is our hello, and grant it the invoke ability to this handler. So if we copy this, go into our hits counter construct, save this. So this is basically saying the downstream Lambda is going to allow this handler to invoke it. And this handler is obviously the hits counter handler inside the constructor. Running CDK deploy one more time, and hopefully for the last time, then we'll now rebuild the Lambdas and deploy everything, and we can test our API. Obviously, because we're allowing a change to an IAM role, so we're saying now we're going to allow Lambda invoke function, and it's the hits counter is allowed to invoke the hello handler. We want to say yes to that because that is what we want, that's the whole point. And then we can test this once this has deployed. So that has finished deploying, but as you can see, it took 49 seconds, and some of you might be saying, why am I not using the hot swap functionality? And that's because we're not just changing, well, we're not changing Lambda code, we're changing actual CloudFormation constructs and CDK resources. That means you can't use the hot swap functionality. So unfortunately, this does take almost a minute every time you want to make a change to one of your constructs or to the stacks. But now that has finished deploying, we can go and refresh our API endpoint. And sometimes you do need to refresh it more than once. But here we now see, good evening, sir, CDK, you've hit /. So that means that we are successfully both hitting our Dynamo table and writing another request, passing that through to our second Lambda function, our hello Lambda. That is generating this message, passing it back. So we can actually add some more things. So if we change our URL to be something like / test path and hit enter, we get a new message of you've hit test path. But if we go into our Dynamo table, refresh the page, we can see that our root has had 4 hits, test path has had 1. And this just proves that changing the URL here, so if we just change it to test, that works. If we now refresh this a couple of times, what we'll see is if we go in here, we can see that test has actually now had 5 hits, test path has 1, and hit has 4. So this now means that we have both of our lambdas working as well as our Dynamo table. And if we go back to our CDK workshop stack, and if I close this, we've created that second Lambda and that Dynamo table and all of that functionality with just this constructor. This is really powerful because we could add more constructors, or if we wanted to use this in a different project, we wouldn't have to rewrite all of this logic again. We could just import the hits counter and pass in whichever Lambda function we want to count. Obviously, this is kind of an example use case, but there are much more useful cases, and we'll talk about that in the next section. In the last video, we talked about how we can use constructs or even create our own constructs and how they allow you to have multiple bits of infrastructure, such as like a Lambda function and a Dynamo table, but all contained within one construct, which allows you to kind of abstract away some of the logic. There are also public libraries that have these constructs. And in this chapter, we're going to be using one called the DynamoDB table viewer. And what this allows you to do is basically say, here is a Dynamo table. I want to be able to have a website that I can view it. So there is this constructor where you pass in the table name and then you get back a URL where you can actually view data from that table. So if we click onto the first section, now what we need to do is actually install the DynamoDB table viewer. So we can, if you can see that very small, we can install the CDK Dynamo table viewer. So I'm just going to copy this, head over to our code, open up a terminal, and in here I'm going to run npm i -d and CDK Dynamo table viewer. And now that that is installed, we can, it says to install it here, and then we can actually go to our workshop stack and import the table viewer. So inside our stack, I can now close these off, and basically underneath our hit counter, import our table viewer. And now our table viewer needs to be passed in a couple of things. Scroll down to the bottom and pass that in. So this table viewer needs the construct it's going to be attached to, which is this stack. It needs an ID, so the view hits counter, and then it needs some props. Its props is a title, so what is the title of our Dynamo table or the web page that's going to be returned, but we also need to pass in a Dynamo table. Now, our Dynamo table at the moment is inside our hits counter, and if we do go here and try and say hits, it's hello hits counter, hello with counter dot. If you look on here, there's a handler, there's a node, but there isn't a table. And that's because we actually need to make a change to our actual constructor to expose the Dynamo table. So back in our hits counter, we need to add this, which is a public read-only value at the root of our constructor. So if we go to our hit counter and underneath the handler, and this is kind of similar to exactly what we did with our handler in the first version where we passed our handler into API gateway, we're now going to enable our table to be public. And once we've got our table, we need to actually pass this. So this.table equals our table value. We can save this, go back, and now when we do hits counter, there is handler, node, and there is a table. So if we just check we've done everything right inside the code, inside the workshop, we've updated our thing to add a public read-only value. We've assigned the table to this.table. And then in the bottom, we've said hello with counter points dot table is going to be the table we're pointing at. If we now go back and open up our terminal, we can run CDK deploy. We could have also been using CDK Watch this whole time, and as soon as we saved this change, it would have actually deployed, but obviously I forgot to do that before setting it up. Now, there may be security related changes, and this is because we've got an IAM role, which is allowing the Lambda, which is part of the table viewer, to actually access our Dynamo table. We want to say yes to this, and then this will now deploy our new table viewer construct. All we know is a table viewer. We're going to pass in a table and get back a URL. All of the complexities of how it's working are hidden inside that construct, which is really nice and reusable. Once this is deployed, we'll see what we get and we can test it all out. Okay, so now that has finished deploying, we have our CDK workshop endpoint, but we also have CDK workshop view hit counter view endpoint and a new URL. So if I copy that and open that up in a new tab, what we'll see once this loads is we get a really nice little DynamoDB table viewer. So we have our path and we have the number of hits. Now this is a really cool little use case. So this has all been generated behind the scenes. All we needed to do was pass in the title as well as the Dynamo table it needs to read from, and it's got the hits, it's got the path, it's got all of this automatically from the config, which is a really good way of showing how you can create useful and powerful constructs and make reusable componentry. If you have any DynamoDB projects, you could use this exact construct to make a little URL where you can actually view all of the data in your table. Now this tutorial does have some extra credits, as you notice as the things in the table, if we look at our table, they're not sorted. Try and figure out how to sort the table by hits in descending order. So what we need to do is find out, is there a way of basically changing the way that the data is rendered in here. So if we go back into our CDK here, what we need to do is check if there are any other props on this table viewer that allow us to basically change the order of the items. So if we look inside table viewer and look at the table viewer props, there's an endpoint type, which we've not used, but that doesn't seem like it's going to be for us. There's the table, which we passed up. There's a title, which is what we used. And then there's a sort by. So here it says the name of the column to sort by. Prefix it with a minus for descending order. So what we can do is we can go back into here and say sort by, and I'm going to start by just doing sort by hits. So if we now redeploy this, actually let's do CDK Watch. So this will do a CDK deploy, and after it's done the CDK deploy, if we make any more changes, it will continue to make those deployments. So as you can see, that has taken 11 seconds, which is a little bit quicker, which is quite nice. So if we go into our hello hits Dynamo table and refresh the page, you can now see that it's ordered, but it's ordered with the smallest ones first. That's because if you actually looked back into table viewer, it says prefix it with a minus for descending order. We want the numbers to be bigger going smaller. So if we go back into here and set this to minus hits and save it, it's going to detect the change because we're using Watch, build it all locally, and then deploy it. And as you can see, that took 7 seconds to deploy this change, which is really quite cool. Now, if we go back in here, and it's already changed so that it says -5, 4, 1 in decreasing order. So that is our extra credit. And yeah, that is now all of the using constructs completed. In the next section, we're going to be looking at some advanced topics, including testing constructs and how to use CDK pipelines. You've now made it to the advanced section of this workshop. I would really appreciate it if you now hit that like button and then learn about testing and pipelines. So the first of the advanced topics is testing constructs. Now, if you've done anything with testing in JavaScript, then you should know about Jest, as it is probably the most common testing framework. And basically the CDK has a built-in version of testing to test against your CDK deployments. So we can assert things and we can validate things using tests. So if we go into assertion tests, we're going to be actually testing our CDK construct to make sure that everything is as expected inside that construct. So to start, we need to add a test directory and then create some tests for hitCounter.tests.ts. So in here, you might, if you use the CDK init functionality, you might already have a test. If you do, then we can just delete that because that was testing the SQSQs that we had right at the very start, and create a new file called hitCounter.test.ts. Now in here we want to basically create a test, and we're going to start by testing that a DynamoDB table was created. To do that, we need to create a version of our stack inside this test, generate the hit counter inside that stack, and then we can say get the template from the stack, and then check that template has a resource count where AWS DynamoDB table equals 1. So if we copy all of this test and go back into our code and paste that in, obviously you can see where there were some things inside the test that needed updating because we need to import all of these properties. So if I'm just going to copy all of these, or you could just import them by highlighting quick fix and then add import, or actually let's try add all missing imports. So that's done some of them, but I'm actually just going to paste in the copied version. So now we have everything that we need. So as I said before, we're going to create a new empty stack. We're going to create a new instance of our hit counter construct, saying apply it to this stack. And then we're also going to pass up a Lambda function because we need a downstream Lambda function. And that is just going to be, again, a node function using the hello.ts. And we're just going to call this our test function. And we're validating that the resource count is 1 for resources that have the type AWS DynamoDB table. So if we run npm run test, this will then create our Lambda functions, and This has actually failed, and it's failed inside the Docker build, and that's because I'd actually shut down Docker. So I'm just going to start up Docker one more time, and then once Docker is running, so let's just check that that is running, and now it's running, we can run npm run test, because we need Docker to actually run the generator for this code to turn the TypeScript into JavaScript. As you can see, now we have a successful pass in 6 seconds, and yeah, that shows that we have a successful test. So if we next go into here, we can see that that's exactly what they got. So the next thing we want to test is we want to create a test for the Lambda function. So in here, we want to actually test that we have a Lambda, and also that we have these 2 environment variables on our Lambda. So what we need to do is go in here, and this is our test, and I'm just going to copy this whole test and paste it into our hit counter.test down here, and then I'll talk you through what is happening at each stage. So again, we're creating another stack, and because it's inside a different test, these will be separate stacks isolated. We're going to create our version of the hit counter in exactly the same way as we did before. We're then going to get our template from the stack, and then we're going to do something called capture. So capture is something you can pass into template.hasResource properties to capture a field or a property on the variable or on the resource. So in this case, we're looking to capture the environment from the AWS Lambda function. And what we expect there to be is we expect there to be a downstream function name, which will reference our test function, and a hits table name, which will reference the DynamoDB table, which will be called whatever you've called the test stack. So in here, we've called it my test construct. So it's going to be my test construct, then the name of the table in case hits, and then some random ID. We also have this AWS Node.js connection refuse enabled equals 1. And this is just an environment variable set when we build our Lambda using the Node.js function. So we just need to make sure that is also on there. If we now save our function and run npm run test, we will see what we get. So as you can see, we've got 1 passed and 1 failed. And the one that failed as is the Lambda has environment variables. Now, what we were expecting is we were expecting it to have these 2 values, but it doesn't seem to have had either of them. It's saying that all of these lines are missing from the environment variables. Now, if we go back to the tutorial and scroll down, we'll see that in here, that is exactly what we expected. And the issue comes from the fact that we have more than 1 Lambda function in our stack. We have the hits counter function, which is the one that we're trying to access, but we also have the hello function. And our tests are failing because we're not controlling which of our lambdas we're trying to get the environment variables for. So we can actually fix this by being more specific in our tests about the environment that we want to capture. So if we go down to the capture section, what we're going to do is instead of just capturing like we do here, where we just are doing an empty capture for everything in the environment, what we can do is we can say we want to capture something that looks like this. So here, what we're doing is we're saying it's going to have a connection refuse enabled, which is going to be the case on both of the lambdas. But then we're saying it also needs to have a variable of downstream function name, which references something that matches a string like test function star. And star here is our wildcard. So we know that this function here is going to be called test function 65394 or something like that. Because we don't know what that 3954 thing is, we can just put a star, which is a wild card. So if we now copy this whole capture section, go back to our code and update our capture. So paste that in. And here this match needs to be imported from AWS CDK lib assertions. We now save that and again go into our terminal and run npm run test. We'll see what we get this time. So the error has still failed, but if we scroll up, we can now see that we actually do have the variable, but it's just referencing a different value. And this is what I was talking about earlier, where it's going to be test function and then a random value. So here we can see that mine in this case is 22AD90FC. And we're expecting it to match test function and then a load of X's. That's because when you first run the test, there is no way of knowing what that value is. So if I scroll down and if I just copy this and switch this one out as same as with the hits table, with these pasted in, we know that we are actually going to be expecting the environment to be equal to the actual value of the test function. So now when we run npm run test, it will go through, rebuild, and hopefully this should now all match and we should get 2 successful tests. That's great, as we've now tested the fact that we are both getting environment variables on our function and that they are matching this reference. Now that we have that, we can go back into here. So the next thing we want to do is we can actually apply a test-driven development approach to CDK constructs. If you've not done TDD before, then it is where you write the test that you know you want to pass, and then you actually write the code to make it pass. So we're going to add a new test for encryption of DynamoDB. So what this is going to do, again, create a new stack, create a new version of the hit counter using this new stack, and then say that template has resource properties, and say, does the DynamoDB table have an server-side encryption specification of SSE or SSE enabled is true. If we now copy this and add this to our code, scroll down to the bottom and paste it down here. When we run this, we'll now expect this to fail because we know we haven't set up any encryption specifically on our, I need to save this file first and then run the test. But we know that we haven't set any encryption on our Dynamo table already. So this is going to fail. And that is the starting state for all test-driven design or test-driven development. You write the test so it fails, and then you go and change the code to make it so that your tests pass. So as you see, it has failed, and if we look at the reason, it's saying that the template has one resource with a Dynamo table, but none of them match this case. That's because they are missing the key of SSE specification. So what we need to do is basically update our hit counter Dynamo table to add the specification. So here, what we need to do is we need to, in our hit counter, find the table and add encryption. DynamoDB table encryption is going to be AWS managed. So if we go back into our hit counter, find our table, and we're going to remove that destroy policy, save that encryption is AWS managed. Now we can go save our file, go back into our terminal, run npm run test one more time, and this is the process of test-driven development. Write a series of tests. You can just write 15, 20 tests for testing the functionality you want to have. Then you write the code and make each of those tests pass one at a time, and now we have 3 tests passed, which is exactly what we wanted. So if we go back to the tutorial, we can see that this has passed, and we've now basically added a load of different assertions to our stack to validate that different things have happened. The next stage is going to be going on to validation tests. So this is going to be a case where you're validating that some process or constraints have been applied. So what we're going to use is we're going to say that our hit counter props actually, instead of using the paper request, is actually going to use provision capacity. And we want it to be greater than 5 and lower than 20. And this is something you can pass into the hit counter when you create it. So we need to modify our hit counter. So copy this code here, head over to our hit counter.ts, scroll all the way up to our props and paste this in. So this is saying that hit counter props has an optional parameter of read capacity, which is a number. Now what we can do is we can go and update our actual table. So we're going to have a read capacity, and it's going to be props.readCapacity, or if that doesn't exist, it's going to be 5. So I'm going to paste that in, and I'm also going to remove the billing mode paper request, because you can't have a paper request Dynamo table that has a read capacity. So now that we have this, we have one more bit of code that we want to add to our hit counter. At the start of our constructor, we want to check and say if the read capacity is not undefined. So if they have passed up a read capacity, the capacity needs to be greater than 5 and less than 20. If they don't have that criteria met, we're going to throw an error saying that the read capacity must be greater than 5 and less than 20. So we can copy this, go back into here, and straight underneath our constructor. So before we get into the super section of our construct, we paste this in here and save this. So this will run before we try and create anything else. So now that we've updated our hit counter to have a property or a prop of read capacity, we can start adding some tests. So we're going to go back into our test function and write a read capacity can be configured test. This is going to, again, create the stack, create a new stack, and expect that when we try and create this hit counter, if we pass up a read capacity of 3, this process is going to throw an error saying that the read capacity must be greater than 5 and less than 20. So if we copy all of that, go back and find our hit counter test, and at the bottom paste this, what we can do is we can go and run npm run test. So that has now finished, and we get 4 passed tests saying that read capacity can be configured. Now this is great, as it showed that if we pass in a value of 3 to read capacity, we get an error. But we also want to test if we can pass up a value of, say, 25 and still get that error. So what we can do is we can basically copy and do another expect, saying we expect hit counter with 25 to get that same error. So if we go back into here and just copy and duplicate this one, but change it from 3 to 25, save this and rerun the test, and we'll see what we get. So that has finished running now, and you can see that we now have 1 failed test and 3 passed ones. If we scroll up, we can see that there is an error for our read capacity can be configured, and it's saying there is already a construct with the name test function in the stack. Now, the reason that that is happening, if we look at our code, is we're creating one stack, adding the test function and the hit counter to that stack. And then in the next test, we are adding the hit counter and the test functions again to that same stack. Obviously, that isn't going to work. So what we can do is we can create another stack. So if we go into our tutorial and scroll down, what we can do is we can modify it by creating a second stack inside this test. So if we just copy that and create a second stack, and what we need to do is we need to make sure that everything in this second test uses stack 2. So that is both the function inside for our downstream function, as well as the hit counter, both need to reference our stack 2. If we now go and run the test one more time, we'll see if that has made any difference. So that is now successful, which means that using a separate stack to define a repeat of our construct is a much cleaner way of doing it and means that we don't get any errors. So if we go into here and scroll down, basically the tutorial is saying exactly the same, but we also want to be able to test if our stack deploys successfully, or if we pass up a valid number, we don't get that error. So we're going to create a stack 3, and this time we're going to say that we expect this not to throw an error. And this .not is super useful for testing the positive and negative cases for anything you use in Jest. So I'm going to copy that, go back to our code, and underneath our stack 2, I am going to add another test in here and save this. So here we have a capacity of 12, which is well within our reach. So if we run npm run test one more time, we should expect this to all pass because we do not expect there to be an error. And as expected, there are 4 passes out of 4 total tests. Now this is okay, but if we scroll up, we just see that there are 4 tests. We have no idea which of the expectations in here have passed. Well, we do because we know they've all passed. So the issue with this is that we only see the fact that there are 4 tests. What happens if actually when we had written the tests, we'd configured something slightly wrong? So if we go into our tests and say, let's have a look at the bottom one. And for example, if we say that this isn't 12, let's say someone accidentally put this as 21 and you save this. Now when we run the test, what we'll see is we'll see that the first 3 tests pass as normal, but the last test, which has our 3 expectations in, that last test actually fails. So the issue with that is that it just says that the read capacity can be configured. That is failing. We don't exactly know why that is failing. So instead of having multiple different cases being tested in one test, we can do something called a describe. So what we want to do is we want to find our test, which wraps everything, and instead change this to a describe. And a describe block is kind of a way of grouping multiple different tests. So I'm going to create a test, and now this is going to just test the first case. So this is going to be a test where it says that we can't configure with capacity 3, and that is going to be a function just like that, and we can cap that off. And if we save this, or actually, yeah, if we save this, we now have this test here inside a block of describe. We can do the same for the second test. So here we say we can't configure with a test of 25, And again, make sure we complete the function, save this. And finally, for the last one, we say that we can configure with a capacity of 12. Now, if we go to the bottom here and close off the function, save this, we now have 3 separate tests within a describe block. Now, if we go into our code and run npm run test, we'll see how the output is different. So again, you can now see that there is 1 failed test, but there are 5 passing tests, which is more than before. And if we scroll up, we can see that we have the first 3 normal tests, but we then have this white block of text, which is our describe block, which groups together these next 3 tests. So we can see that the can't configure with 3 is passing. We can see that the can't configure with 25 is passing, and the can configure with 12 is throwing an error. That means that we know that this is the test case that is erroring, so we can actually go and look at the test case. Obviously, as we know, the reason that this is failing is because we've done a little typo. Instead of configuring the read capacity to 12, we configured it to 21. So if we now save this and change it back to 12, which is what it's meant to be, and rerun the tests, we'll obviously see all of these tests passing, but we're able to actually group blocks of tests together using a describe block, which makes it much easier to both understand when you're trying to tell what different tests are doing, but also when you run the tests, having read capacity configured, you could have another describe block, which is something like DynamoDB configuration tests, which would have the first and third test grouped together, so that if there was something wrong with Dynamo, you knew which tests you could be looking at. So the last section in this CDK tutorial is CDK Pipelines, where we are basically setting it up so that we can have continuous deployment for the app that we've created. And continuous deployment is an important part of most production-ready systems. And with this, we can define the pipeline inside the repo, which means that we don't have to have a separate repo, or even worse, create the pipelines manually. It can all be done in one nice self-contained repo. So if we go across to getting started with the pipelines, what we need to do to get started is create a new file under lib called pipelinestack.ts. So I'm going to create that file here. So create a new file, pipelinestack.ts, and we're just going to create a new class or a new construct, and just for now leave that as blank, and this should look very familiar. Now, one of the differences is before, what we were doing is we were using the app, and in that app we were creating our project and creating our our workshop stack. This time, instead of creating the workshop stack inside our app, we're going to create our pipeline stack. So if we I'm going to copy this bottom line, head over to our code and go to our bin/CDK workshop. Instead of including the workshop stack, we're going to delete that and replace it with the workshop pipeline stack, and import that from lib pipeline stack and save that. This means that our app is now deploying a pipeline, not the actual stack itself. So now that we've got that, we're ready to build our pipeline. So the first thing we need in a pipeline is a repo to actually contain all of our code. So we can copy this, and this is just creating a code commit repo and calling it workshop repo. So if we go back into our pipeline stack, we can delete that one line and paste this. Obviously we need to import code commit. So if we highlight over this, quick fix, for some reason it's not quick fixing, but we can import star as code commit from AWS code commit in the libraries. So just do that. And now what we can do is actually create this repo using CDK. So with everything saved, we can run CDK deploy, and this will deploy our new stack. And this time our stack is going to be coming from here. So it is just going to be the workshop pipeline, which at the moment, the only thing that's going to exist is a new repo called workshop repo. So this has taken only 14 seconds to create. So if we go back to tutorial, the next thing we're going to do is actually get our repo and get our Git credentials. So before we do that is we go into our AWS account, and if we search for CloudFormation, we can actually find our most recent stack. So that's the CDK workshop pipeline stack. And if we look inside here, we should have a resource of the workshop repo. And there we go. We have that repo. So we can find that in code commit. And in here, we have our workshop repo exactly as we expected. And it was last modified a minute ago. Back in our tutorial, we need to create a set of credentials to actually access this repo. So we need to go into our IAM console, navigate to users, and then either select or create a new user. So I'm going to go for IAM in here, open it up in a new tab. In here, select on users, and I'm going to create a new user. And this username is going to be workshop user, and create next. So in the next step, what we need to do is define the permissions. And for now, I'm just going to leave this as empty because we don't want to attach any policies just yet. We're in the summary page, so we want to create our user. Now that we have our user, we can go into here, go onto security credentials, and scroll down to Git credentials for code commit, and we want to generate credentials. Now we have this, we're going to leave this page open for a second, and what we're going to do is we're going to go into here and find out the next step. So what we need to do is actually add a remote to our repo so that we're connecting our local code up to this code commit repo. So find our repo, and then we're going to clone the URL via HTTPS. So I've still got that page of repos open, and I'm going to clone URL via HTTPS, which has now been copied. With that copied, we can go back into our terminal and make some changes. So in here, we can run git init. And with that, we can then run git add dot git status. And now we can see all of the files that have changed. And we can see these are all of the new files that we are adding to our project. What we can do is add a commit message. So git commit -m for a message, and then our message. So I'm going to say creating hit counter project. So now we have committed that. We have 0 local changes in here, which is exactly what we expect. And now we want to actually add this to our remote URL. So here we can run in our terminal git remote add origin, and then we need to paste in the URL that we got from the repo inside the console. So if we run enter on that, we can now run git push -- set upstream origin, if I can type this properly, and master, because we are in the master branch. Now here it's saying we will need to enter our username to be able to push to this branch. So if we go across into our IAM account, and we now have our username, so I'm going to copy that and paste that in here. And now it's asking for our password, so I'm going to copy that and paste that in as well and hit enter. Now this has actually failed, and the reason that has failed is if we go into our user and we find our permissions, we currently have no permissions. So what we want to do is add a permission, and we're going to attach policies directly. And in here, we want to type in code commit, and we want to say code commit full access. So just click next and add permissions. And now this user has the permissions to access code commit. Now if we go back into our terminal and rerun git push upstream origin master, it will ask for our username again. So I'm going to paste that one in. And our password. And this time, because our user now has permissions to write to the code commit, we have created our workshop repo branch. If we go back into our repos and open up the repo, we'll now see that all of our code is exactly here, which is exactly what we expect. So now that we have the workshop repo up and we have our code in there, we actually want to add our pipeline. So if we go across into our tutorial again, we can find in here, if we go to creating the new pipeline, that inside our pipeline stack, as well as having our repo, we also want to add a pipeline. This pipeline has a name, but then it also has a synth stage, which is where we are synthesizing our output. And that is always going to be a cloud build step that ends in a CDK synth. So what we want to do is we want to copy all of this, head over to our code, and paste this underneath our code commit repo. Obviously, there needs to be some imports. So if we go back and look at our code, we can import all of this from the CDK libs/pipelines. But let's see if we can just mouse over this and do a quick import. So if I import that from pipelines, we can import this from pipelines as well as this. And now here we are referencing a repo to attach this pipeline to. So what we need to do is change the definition of our repo to be const repo equals, so that we are basically able to pass this repo into the next stage. If we save all of that, we can go over back to our code. And in here, what we need to do is we need to run a commit or create a commit message and then push that change up and do a CDK deployment. So if we open up our terminal and run git add dot git status, so this is the way I like to do it, so we can see that we've modified the pipeline, git commit -m, and this message is going to be adding a pipeline git push, and now that has pushed up. And if it's asking for your password and credentials again, that's because there has been a timeout. And now once we've done that, what we can do is we can run CDK deploy, and the CDK deploy will now deploy the pipeline, and that pipeline will listen for future commits. So running this CDK deploy, and then we can look at what the next step is in the process as we go back. Actually, sorry. As always, if we are changing some permissions because we're now passing a repo into a code pipeline, there's going to be some IAM changes. So we need to just confirm that we are okay with those. And then once that is deploying, we can head over back to our tutorial. And here, once it's built, we should be able to find this pipeline and see the different steps. So this is in progress, but I'll show you that once that is done. With that completed, we can head over to our AWS account. And if we instead look for code pipeline and open this up, we should see that there is a workshop pipeline And in here, we can see that there is a source, which is our workshop repo, and then there is our build. We can see that this has actually failed because there was no branch named main inside our selected AWS commit repo. So if we go back into our code, we can see that this says main, even though in our repo, we've been calling it master. So what we can do is we can change this from main to master, save this, and run CDK deploy. Okay, so this has now deployed again. So if we go back in here and refresh this page, now we can see that we have successfully pulled from the source of workshop repo, but inside our build, this build has failed. And if we scroll down, we can see that this has edited because it can't find the module of AWS Lambda. If we go back into our code and look at hitcounter.ts, we're importing API gateway from this AWS Lambda, but obviously we haven't got it installed. So npm I -d, and then it's at types /AWS Lambda. And once we've installed these types, this error should go away. So with this updated, we could just commit this, git add dot git commit -m import AWS -lambda git push, and this will now deploy, and that will trigger our pipeline. So if we go across into here and go to our pipeline, close out of this and go to the pipelines, you can see that the latest execution is now in progress, so we can check back on that in a second. If we go across to our tutorial and go to the adding application pipelines, what we need to do is we need to create a new pipeline stage. So we want to create a new construct inside the lib folder. So in here, create a new file called pipeline-stage. And we want to basically copy this code. And what this is doing is this is creating a new stage. And this stage basically has an instance of our CDK workshop stack. And we're just going to call this web service. So this means that this stage contains our stack that we actually want to deploy. So now that we're calling this workshop stack using this, so from a construct instead of from the application, we need to make sure that inside our CDK workshop stack, that the scope here is a construct and not an app. You may have updated this already, but if not, all you need to do is change this to be a construct, as said here. Everything else will stay the same. And now what we can do is we can add this stage to a pipeline. In our pipeline stack.ts, we can add a deploy and a deploy stage to our pipeline. So go to our pipeline stack, and at the bottom underneath our pipeline, we're going to create a new workshop pipeline stage, which we can import from pipeline stage, and then save all of this. With this, what we're doing is we are basically importing our stage and creating a deployment, and then adding that deployment as a stage on our pipeline. Now we've got that, we can basically commit that and push that up. And here's a command to both add everything, add a message, and then push up all in one go. So make sure everything is saved, paste that in, and hit enter. That will save everything and push it up to master. If we quickly go back across to our pipeline and click in here, we should be able to see that previous steps have built and updated the pipeline, and now it is in progress again, running the most recent commit. So now we've pushed that up, we can go across into our code pipeline, and we can see that it's gone through 3 hours ago, and it has updated the pipeline, created some assets, But the new things that we get now that we have this deploy and deploy stage is we have this section here. And here you can see it prepares our CloudFormation and then deploys it. If we actually click on this CloudFormation, it will open up in a new tab to the deploy web service. From here, we can click on our resources, and if we open it up, we can see inside our web service there is the hello handler and the hello hit counter, as well as the view hit counter, which comes from the DynamoDB table viewer. So that has now all worked, and what we've got to do is go into the last stage. The issue is that although if we go into our workshop pipeline, go into CloudFormation, in here we can then open up our endpoint, look at the outputs and get our URLs. That isn't the most elegant way of doing things. What we can do instead is we can make sure that we are exporting them. So if we go into here, we can actually edit our CDK workshop stack to have two public values. So what we're going to do is we're going to copy that and go across into our workshop stack. And in here, we can go and find this. And we need to paste this above the constructor. Paste those in there. And we just need to quick fix the import. So this is coming from CDK, so that's this top line here. And import that just like that. Save that. And now we are declaring these two values. But what we actually need to do is we need to create these URLs as outputs. So at the bottom of our stack, what we need to do is we need to actually create the HC endpoint and the HC viewer URL. So if we copy these and go back to our code and paste them in, what we're doing is we're saying the public read-only value of the hit counter endpoint is going to be a CloudFormation endpoint. It's going to be called a gateway URL, and then the value here is going to be gateway.url. But we haven't defined a gateway. That's because this is coming from API gateway, so we need to say const gateway equals a new gateway. And now we can do that. Similar to here, we have this value for TV, which is our table viewer, and we haven't got that exported. So we need to say that const TV equals table viewer. And now the hit counter viewer URL, which is the URL we looked at our nice little table for, is going to be the table viewer dot. If we now save this, go into our terminal and basically add our new change, so git add dot git status git commit -m, and I'm going to add the message of making HC endpoint and HC viewer URL, and I now git push to push this up. It will update the code inside our code commit. That will then trigger the pipeline that we've also created in here, and that will update the values or the outputs from here. One thing to note is that if at any point in this asset build you get an error where one of the file assets is failing to build, you can click on the view details and it might say something like start build cannot have more than one build in the queue for the account. Now that means that basically file asset 1 was being built, file asset 2 was the first one in the queue, so file asset 3 was going to be the second one in the queue, but as the error message says, you cannot have more than one build in the queue for this account. Now this is just a service limit, so this can be lifted, but for now what we can do is we can say retry failed actions, and what this will do is this will retry any of the actions that have failed within this step so that we can continue. To actually increase these limits, what you can type is service limit. So sorry, service quotas. And then in here, what you can do is you can say, I'm looking for a code build quota. And in here, we want to search for Linux. And what we can find is that there are quite a few different settings, but the ones we want to do is we want to say that for the small environment, we are currently allowed to have one concurrent build. So what we can do is we can request an increase, and let's increase this to, let's go with 10. So now that we have that, we can request this, and we'll see if that has been processed. So quota increase requested, and hopefully what that should do is when you do run it in the future, it won't cause that issue when you have 3 or 4 different tasks in the build pipeline all at the same time. They'll just work. For now, we can close this tab, go back to our workshop pipeline, and we can see that our deployment has finished again. So if we go back into our CloudFormation and refresh this page, what we can see here is we now have a gateway URL CloudFormation export and table viewer URL. And these are values that we know beforehand because we explicitly pass them in inside our code here and here, so that we can reference them either in other packages or other repos, whereas before we just had endpoint and then a random string of numbers and letters, which we wouldn't be able to directly reference. Now that we have that, we can actually go through and do some testing on our pipeline. So we have our pipeline all perfectly created, but obviously no pipeline is truly complete without adding some tests. So if we go back into the tutorial and scroll down, we want to start adding some tests to our pipeline. To do this, we're going to return to our pipeline stack, and we're going to add an extra stage onto the end of our pipeline. What we can do is, after the deployment stage, we want to add a post deployment step. So if we copy all of this, head back into our code and head to the pipeline stack. After here, we want to paste this in just like that. And we then have our URLs here. And what we're doing is we're creating a code build step to test the viewer endpoint. And what we're going to do is we're going to pass in the endpoint URL. And then we're going to basically say, run a curl command on this endpoint. We're going to do exactly the same with the API gateway endpoint. So this is our hit counter. And we're going to pass in the endpoint URL and do some different requests to different endpoints on our hit counter and make sure that they all succeed. Now, as you can see here, there is a endpoint URL that we need to pass in, but we don't currently have that. We need to go into our workshop pipeline stage. So when we actually deploy our CDK workshop, we need to pass this back through to our pipeline so that we can actually access the values. To do that, we need to create 2 public values on our actual stage. So let's do that first. So in our stage, before we do the constructor, basically say we want to create a CloudFormation output, and we can import that CloudFormation output from the library. We now can actually set the HC endpoint as service dot, and if I just paste this in here, it'll make a little bit more sense, and save these. But obviously service hasn't been defined, so we're going to say const service equals whatever the output from the CDK workshop stack is. The fact that we can say the HPC endpoint and HC viewer URL was what we went through before, where inside our stack we created these 2 CloudFormation CloudFormation exports, so that we can access them inside our stage and then make them public so that inside our pipeline we can actually access them. So now that we have this available and set up inside our stage, we can go back to our actual deployment, and we can add that. So we know that the deployment is the result of the workshop pipeline stage. So what we can say is we can say here deploy dot, and here we want to say that this is the viewer URL, and this endpoint is going to be deploy dot hit counter endpoint. If we save all of that, we now have 2 extra stages to our pipeline to try hitting our viewer URL and hitting our hit counter endpoint. If I save all of these files, to actually deploy this, we can first commit our change. So git add dot git status git commit -m, and my commit message this time is just going to be adding tests to pipeline and hitting send. Now, as well as doing tests like this, you could actually use something like Jest and have other tests, such as the tests we wrote earlier with the hit counter tests. We could have all of those automated as well. We can head over to our code pipeline, and we see that it's going through and doing a build because we made a commit. But if we scroll down, we can actually see that in our deploy step, we have the prepare and the deploy, which we had before, but we now have 2 extra steps. We have the test API gateway endpoint and the test viewer endpoint. So these will actually get executed when the pipeline gets through to this stage, and then I'll show you what happens. Having these very simple tests in here is kind of like a smoke test to ensure that once our deployment has actually run, that our endpoints are available. So in this video, we have covered a lot. We have set up a CDK project and created our first hello.ts lambda function. We were able to test that and see how we can use things like CDK Watch to very quickly and iteratively deploy our code instead of having to wait ages to deploy the whole stack. We then moved on to writing our own constructor, where we can pass up a lambda function into our hit counter, and it will basically measure the number of times that lambda function gets called and log out the number of paths inside a DynamoDB table. From there, we then added another construct, which was the table viewer, where this is an example of using other people's constructs to simplify our development process. From there, we were able to move on to testing, where we took our hit counter constructor and tested different things, such as does it have a Dynamo table, does it have a lambda, and does that lambda have the correct environment variables. From there, we also moved on to validation testing, where if we put limits on the props that you pass into our constructor, we can test that those work effectively. Finally, we used the CDK itself to build an AWS build pipeline, and that meant that whenever we commit our code to our code commit repo, it starts the process, builds it, uses that to then generate the CDK template for our actual deployment, and goes and deploys that into our AWS account. We even added some tests at the end of our pipeline to make sure that our endpoints were there and that we could invoke them. If you've made it all the way to the end of this video, then I would really appreciate it if you smash that like button and leave a comment below saying what you're going to build with your CDK knowledge. The reason I created a video on this whole tutorial and workshop was because when I went to do the workshop, I found that it was really out of date. I've just spent the past week and a half updating this workshop and making it into what it is today. If you want to see what the process is like for updating a AWS workshop and trying to give back to the community, then check out this video here where I talk through the whole process.